and some other third device simply by changing only those templates, only the HTML, only the CSS, but all of the hard work that you put into the site, all of the true logic, the database calls and the like, can live independently. And so among the themes of the course will be designing your own APIs and sitting down with your partner and deciding with him or her what methods or what functions you're going to implement so that he or she can assume that those functions will exist when his or her code calls those functions. And so we'll be able to divide work much more effectively when it's no longer just one of you, but multiple folks together. So lastly, in PSET 8, we use the Google Earth and the Google Maps API. And Google's JavaScript libraries are really actually illustrative of some of the more advanced things you can do with JavaScript. So JavaScript allows us to do things like this, where in this first line, this is what we'll eventually call a factory pattern, where you have some kind of special global object, .createPoint, which apparently is creating a new structure called a point. So you could actually do this with other syntax. We used malloc in C, we used the new operator in JavaScript and also PHP, but this is representative of a design pattern that we'll look at, where if you want to create multiple copies of some kind of object, you can relegate that functionality to what we'll call a factory. And here is perhaps a very canonical example of what we'll do in most every one of the languages we use this term. We have a variable here at left in JavaScript. We call the keyword new, which says give me a new chunk of memory and invoke the following function, in this case a marker function, which is designed to look like what's a constructor? Those of you who took APCS or the like in high school might recall from Java constructors and the like. Well, this is a way of implementing that same idea, but as we'll see in JavaScript, there aren't classes per se, but these things called prototypes. But this too will allow us to discuss some other aspects of that language as well. So without further ado, let me pause for a moment and introduce our two courses heads, Rob Bowden and Tommy McWilliam. If you'd like to come up here and say an awkward hello.
Hi there. So for those of you who don't know me from CS50, my name is Tommy. I just want to emphasize that whether you're coming from CS50 or if you've taken as many CS courses as Rob, that you really have a lot to get out of this course. Because really we're focusing on engineering and skills that can really be applied to any of your side projects or any other CS course that you're going to go on to take here. So we certainly hope we see you this semester.
Hi. I'm Rob. I can't tell you all good work quite yet, but if CS50 was any measure, where I was just so impressed by all the projects I saw, then I'm sure when we come back here, however many weeks long a semester is, that I'll be able to stand up here again and just tell you how proud I am of all of you.
And then structurally, what's in store for us this semester? So, and you will meet, as an aside, the rest of the team over the course of this week and next. So, topics among which we'll explore this week. So abstraction, encapsulation. So these are the buzzwords, or really the fundamental ideas behind a lot of the language features that we're going to really start to take advantage of and appreciate ultimately. Abstraction being this idea of being able to implement, for instance, a linked list that's not hard-coded for ints, that's not hard-coded for students, but it's just a linked list inside of which you can put any piece of data that you want. And to do that, you encapsulate information. You encapsulate the next pointer. You encapsulate the head of a list, potentially. And so these themes will recur as we start to design software better. So we'll look at these ideas of classes, prototypes, and objects, some of which you've probably seen in AP Computer Science, if that is your background. But we'll look at it in all sorts of contexts, as well as how it's used differently in these various languages. We'll look at more sophisticated, object-oriented techniques. So what is, first, though, this buzzword of OOP, object-oriented programming? It really does boil down to taking structs to the next level, being able to associate inside of some container not just properties or variables like students' names and IDs and the like, but functionality as well, so that you can build into a linked list or build into an array the searching functionality or the sorting functionality, so that you can build into a student object the give me your first name functionality, give me your initials functionality, so that when you say foo.bar, bar no longer needs to just be a variable, it can actually be a function, otherwise known as a method that you call. So these words really are synonymous. Function is when you're using procedural programming like C, where you have no classes and objects. A method is just a function that's inside of, so to speak, an object or a struct. So more on these buzzwords over time. Polymorphism is a fancy way of saying that you can actually have hierarchy among your objects. So you can have, for instance, a human object, and then you can have a man object and a woman object that both share some common functionality or features, but themselves have disparate characteristics as well. And yet both man and woman are humans. So objects can behave in the same shared way, but you don't have to know in advance whether the object that you have in your array or your linked list or the like is one or the other. You can genericize it as this is an array or a linked list of human objects. And we'll see this more before long. Interfaces. So when I mentioned or picked on the dictionary implementation before, where we said you have to implement check and load and unload and the like, well, an interface is a way of saying my class, my struct, will provide you with all of this functionality. I don't know how I'm going to do it yet, but I commit to providing this functionality. So very often throughout the semester, what you'll probably do with your partner is sit down at a whiteboard or chalkboard and decide between each other who's going to implement what functions or methods each of you is going to implement, what arguments those methods will take, what the return values will be. Then you'll go back to your respective computers or homes. You don't even need to see each other in theory for the rest of the period until you then to come back together and know that if you've at least implemented what you promised to implement, that code should be wireable together. Now, invariably, this is not going to work, right? So not certainly the first time. So more intercommunication will be necessary, but this is the idea, so that when you start to collaborate with folks, you're not going to both work on the same piece of the project. You're going to decide what lines you can draw and just make a commitment to one another to implement that functionality so that the other can depend on it. But what will happen quite often is you realize halfway into the week, halfway into the project, damn, that was not really the best design decision. So you're going to have to revamp your designs and your interfaces and what your code looks like so as to solve some problem that your partner or you didn't even realize that we were going to have until you tripped over it. We'll talk to you in the course about design patterns. So these are buzzwords that are often applied to techniques for writing code. The more you program, especially if you've only been in 50 or just one other course, you'll find yourself over the course of future semesters and even years that you're kind of writing the same kind of code a lot, and you find yourself perhaps solving the same problem again and again. So maybe even you, industrious as you might be, might write some helper file, a file containing all sorts of functions that you find yourself using quite a bit so that you can start reusing that same code. And so here too, we'll talk about common ways of writing code so that you can solve problems more generally, and not just for this problem, but you can reuse that code for other things. Singletons, factories, one of which I mentioned earlier, observers. These are just a few of the pieces of jargon we'll explore that aren't really fancy things unto themselves. In fact, you might have been writing code that adheres to these patterns already. You just didn't have a word for it, but these patterns typically allow you to expedite solving of problems that other folks have already had. So this is something, too, that will prove invaluable. Bureaucratic though it sounds, writing tests for your own code is hugely valuable, especially as your projects start to grow in size. I mean, even think back to the last CS course you took, whether 50 or 61 or something else, whereby you wrote your project and you think everything was working, you'd ran some tests, but then you went back maybe 5 minutes before the deadline, changed something, and then a whole bunch of things broke, and your code regressed to some earlier state where not much was actually working. Well, imagine a world in which before you actually resubmit that code, you run a command called test, and your code tells you yes, no, yes, no, yes, no, it does what you expect. So this too will become integral to the process of writing these projects for your own sake and your partners. And because as you start to write dozens and hundreds and even thousands of lines of code, if you make one change over here, testing manually the other 999 lines of code that you wrote to see if you broke something elsewhere is just not something you're going to want to do by hand. And so there's this great comfort you'll start to derive by writing tests for your code so that when you do change something, you don't even have to think about the rest of the code. You can run your test, and if it passes, you know you didn't break anything. Now that too is a bit of a lie, right? Because invariably you won't have tested everything you should be testing. But here too is an opportunity when your partner or when a classmate or when your TF does in fact find some bug or some fault, that's kind of a wake-up call like, damn, I should have caught that. But okay, not a problem. Write a short test, and by test I mean a function that calls your function and examines the output. Is it what you expected to be? We'll write a new test so that the next time you work on this project or code, you're not going to make that same mistake again, because that new test will detect the mistake that you've just made. So this is generally known as unit testing. So we'll also talk in the course about user experience. So this is kind of the silly, sexy term that people use to describe user experience these days. And it really refers to the design of user interfaces and the actual UI that humans interact with. And I do recall fondly from CS50 the past couple of years how we've assigned you the task of critiquing some piece of hardware or software with which you find fault, most of which were within somewhere harvard.edu. But it's that kind of discussion we'll have so as not to just pick on and bash on badly designed software or hardware, but to actually think about what is it that makes that particular tool that you might all be about to use so bad, right? And how can you avoid those same pitfalls? And what can you do better? So we'll be on the lookout throughout the semester for things folks do well and things folks do less well. Performance too. And here's something where the mobile context allows